Hi, this is Mona. Welcome to my channel. This video is part of my beginners friendly AI playlist. If you're completely new, I recommend watching the whole series from the start. Otherwise, I recommend checking out my more advanced courses instead. I'll go through 5 modules, each divided into 2 parts, where I'll cover the key foundational concepts you need to get started. Let's dive into Module 5, Part 1. Today I want to talk about something really interesting. Let's take a step back and understand how all these AI terms, generative AI, AI agent, and agentic AI fit together. It might sound like a lot, but they're really just different stages of the same evolution. This story begins with something called GPT, which stands for Generative Pre-trained Transformer. That's the mouthful, so let's break it down. Generative means it can create, write, summarize, or produce new content. Pre-trained means it learned from a massive amount of data before you ever talk to it. Transformer is a type of neural network architecture. It uses the secret sauce that allows it to understand context and language. The first version, like GPT-1 and GPT-2, were basic language models. They could form sentences but not really converse. Then came GPT-3 and ChatGPT, and suddenly we had models that could talk like humans, reasons through the problems, and generate creative content. That's when generative AI truly became mainstream. So generative AI is the foundation. There are models like GPT-4, DALL-E, or Cloud trained on enormous data sets, everything from books and code to images and audios. Their main job to generate new things, text, stories, music, art, or even videos. But there's a catch. Generative AI is reactive. It waits for you to act first, you ask, and it answers. It doesn't take initiative or do anything on its own. Think of it like a super creative friend who can write you a story, design a logo, or compose a song, but only after you ask for it. Then came the next step, AI agents. This is where things got interesting to my mind. Instead of just answering questions, AI models started doing tasks and an AI agent is like giving your smart AI friend a set of tools. Now it can browse the internet, check your email, analyze data, or even write and run code. For example, you say, find me the most recent research paper on renewable energy and summarize it. A regular generative AI might say, I don't have access to the latest data, but an AI agent could actually search the web, read the papers, and give you a summary. So while generative AI creates, AI agents act. They're, what I'm trying to say is that they're the doers of the AI world. Let's move on. Now we arrived at the newest and most exciting frontier, agentic AI. If AI agents are like individual helpers, agentic AI is about many AI agents working together toward a shared goal. It's like turning one smart assistant into a coordinated team of specialists. Let's take an example. You want to turn a YouTube video into a blog post. One AI agent transcribes the video, another summarizes the key points, another writes the blog post, another design a thumbnail image, and another format and upload it to your website. All these agents communicate, share result, and adjust based on feedback, sometimes even looping in a human for a review. That's agentic AI, where the focus is not just on generation or single task automation, but on collaboration, coordination, and autonomy across multiple agents. Think of it like this: generative AI equals to one creative artist. AI agents could be that artist who can also use tools and take actions. And agentic AI is something like an entire studio of AI artists, editors, and managers working together toward one creative goal. So, when ChatGPT first launched in late 2022, it was simple. It answered your questions and generated responses. You had to give it a good prompt to get a good result. Then GPT-4 arrived, and the AI became more capable, not just answering, but reasoning, analyzing, and even helping as a kind of digital advisor. Next came custom GPTs, or personalized version of ChatGPT, which allowed people to build mini AI assistants trained for specific purposes, like a recipe planner, or coding helper, or a career coach. This was the earliest step toward AI agents, models that don't just talk but act and specialize. Now, the next step is agentic AI, where those individual assistants can work together, make decisions, and adapt on their own, almost like a mini organization made of AI or AIs. That's a direction the industry is heading, moving from reactive answers to active problem solving or autonomous collaboration. What I'm trying to say is that early models responded to direct question with generated text, sorry, then AI agents began taking action and using tools to solve tasks. So, agentic AI systems coordinate multiple agents for complex workflow. Here's the whole story in one line. Generative AI creates, AI agents act, and agentic AI collaborates. And behind it all is the evolution of the GPTs, from simple language models to powerful decision-making systems that are starting to shape how we work, learn, and create. It's summarizing to think that this transformation from chatbots to multiple agent ecosystems has all happened in just a few short years. So we've reached to the second part of this video. I'd like to talk about RAG and fine-tuning, how they work and their difference, and other related topic. In previous video, we learned about vector database and embedding and how I can explain you. And now I can explain you how they join together. But meanwhile, before dive into, if you found this helpful up to here, don't forget to like and subscribe. And if you have any question, drop them in the comments. I'll happy to answer. Let's move on and be sure to keep going. Those moments when ChatGPT or other AI models sound super confident but give you totally wrong answers. That happens because these models can only use the information they learn during training, which means anything new or updated after that they simply don't know. We talked about it in previous pages, and sometimes it's known as a hallucination. You might ask which planet has the most moons. If the model was trained before 2023, it might say Jupiter with 88 moons. But if you check NASA today, it's actually Saturn. As of March of 2025, Saturn has 274 moons. That's a big difference, as you can see. That's where RAG, or Retrieval Augmented Generation, comes in. Think of it like giving AI its own fact-checking superpower. RAG combines two things: retrieval, which means searching for the latest, more relevant info, and generation, and it means writing the answer clearly using what it found. So instead of guessing from memory, RAG looks, think of things up first, just like we do when we're unsure about something. Here's how RAG works in practice. The first one is retrieval. The AI searches through a reliable reference library. This could be websites, PDF, company files, or databases. For example, checking NASA's site for current moon counts. And the second one is generation. Then the AI uses what it found to write an accurate answer in natural language. It's like having a super smart friend who always double check before replying. Let's move on. But the best part, how about the best part? When new information comes out, you don't have to retrain the entire AI model. You just update its reference library. It's flexible, fast, and keeps your AI up to date. And if the AI cannot find the answer, it's smart enough to say, I don't know, instead of making things up. So think of RAG as AI with a built-in fact checker and library card. A RAG pipeline usually have various components that interact with one another. The most essential building blocks are the following briefly. The first one is data ingestion and pre-processing. Raw knowledge sources in various forms, such as documents, web page, and PDF, are loaded into the system. And pre-processed, I mean conversion into standard format, content extraction, normalization, and many things else, aligned with various text processing. The second one is chunking. Each document is split into a smaller, semantically meaningful chunks. The chunking step is essential for effective retrieval since it sets the granularity at which information is indexed and retrieved from the database. Sorry. Embedding generation is another one. Every chunk is embedded into a high-dimensional vector using a language model. And the next one is vector database. A vector database or index stores all chunk embeddings while supporting similarity search and also retrieval engine and generating pipeline. But I don't like to confuse you. That's why I think it's enough for now. However, I should mention that the goal is for all components to work together and turn raw data into an accurate and contextually relevant and up-to-date answer. Let's move on. And I want to talk about making AI local. I mean, RAG helps turn general AI into a local expert for your specific needs. Company uses, for example, internal policies or procedures, product manuals, or technical aspects, meeting notes or project documents, or maybe project documentation and deep data, deep report or client FAQs. And personal uses is something like your resume or portfolio, team processes and workflows, project or client specific info. Basically, RAG gives you an AI team member who's read all your documents and docs and remembers everything accurately. Let's say you upload your company's internal documents or report into a RAG system. When you ask, what's our refund policy, or how does our AI handle user authentication? The AI doesn't rely on general internet knowledge. It retrieves answers directly from your company documents. Let me give you another real example, a real world example from logistic industry. Imagine a company that imports goods through different countries every few weeks. Custom regulations, tariffs, and clearance rules get updated, and sometimes even daily. For every shipment, the company must check whether its document, invoices, and packaging meet the latest custom requirements before the cargo can be cleared. Now, without RAG, this is a nightmare. Every time a new regulation comes out, someone has to manually read the updated documents and figure out what's changed. Then they'd need to retrain or reprogram the AI system just so it can understand the new rules, which takes time and money. But with RAG, it's much simpler. You just upload the latest custom documents and regulations to the RAG system. When a shipment arrives, the AI automatically retrieves the newest rules and compares them to the shipment's paperwork. Then it generates a clear answer like this. This cargo complies with the current customer rules, or the shipment is missing the new import license required since, for example, October. So instead of retraining the model every time the law changes, you simply update the documents, and RAG immediately adapts. That's why, in fact, in fast-changing fields like logistic, law, or finance, RAG is becoming a game changer. It keeps AI accurate, up-to-date, and compliant with real-world changes. Let's move on. RAG is a method where the model retrieves information from an external language source like company document or databases at runtime to provide accurate and up-to-date answers. The key point is the model itself is not retrained. External documents are stored in a vector database, and the system finds the most relevant text and sends it to the model with the user's query. And great for dynamic knowledge that changes frequently. For example, the chatbot looks up answers in company manuals or policies whenever a user asks a question. So we have heard about fine-tuning as well, haven't we? However, we want to know about this question. What is fine-tuning? Fine-tuning means retraining a base model on custom examples so it learns specific behavior, tones, and domain knowledge. And the key point is the model weights are updated and it learned from input-output pairs, for example, sample conversations, and useful for teaching the model style, tone, or consistent formats. And last but not least, not ideal for large or frequently changing data. For example, training a support assistant to always rely in a polite and brand-specific tone. Now you might ask, what about fine-tuning? Doesn't that also teach AI new stuff? Here's the difference. If we consider fine-tuning and RAG, and if we want to compare them together, I should say that what it does and what is best for, and which one is best for. Fine-tuning teaches the AI new patterns or behavior by retraining it on examples, and it's best for style, tone, and task specialization. For example, writing, like your company. And a RAG lets AI look up fact from an external source in real time, and it's best for keeping information fresh, accurate, and private. So if we want to mention something that is related to the feature, I should say that, yeah, maybe setup time for RAG is quick and for fine tuning is longer. And for example, when it comes to hardware, for RAG, no GPT needed. No GPU needed, but fine-tuning required training infrastructure if self-hosted. And what else? If I want to say about something about data update, I should say that for RAG it's easy and fast, but for fine-tuning is required retraining. So, if you want your AI to sound like your company's tone or follow your process, you use fine-tuning. If you want to answer a question based on your document, you'd use RAG. And sometimes the best system use both together, fine-tuning for personality and RAG for knowledge. Fine-tuning can be categorized by the methods of parameter adjustment, I mean like full versus parameter efficient, or by training objective like supervised instruction or unsupervised. Full fine-tuning updates all model parameters, while parameter efficient models like LoRa and adapter only just a small subset, requiring few computational resources. Other type include supervised fine-tuning or SFT, which uses labeled input-output pairs, and instruction fine-tuning, which trains the model to follow natural language model. And yeah, about parameter adjustment, I should say that full fine-tuning, all model parameters are retrained and high accuracy, but require large data sets and strong GPUs. And also about parameter efficient fine-tuning or PEFT, it updates only a small subset of parameters, making it faster and more computationally efficient, and only part of the model, like adapter layer, is trained. And common PEFT methods is LoRa, as I mentioned before. It means low rank adaptation, which is a popular method that adds small, trainable, low-rank material to the model. And finally, adapter inserts new small layers into the model to be trained while the original weights remain frozen. And when it comes to training objective, we have some options. For example, supervised fine-tuning, which is SFT, briefly, trains the model on the data sets of labeled examples like input-output pairs to perform specific tasks such as text clarification and instruction fine-tuning. We have it. It means train the model on a data set of instruction and corresponding responses, helping it generalize to follow command and answer question. And unsupervised fine-tuning means fine-tunes a model on a large corpus of unlabeled text from specific domains to improve its general language understanding in that field. And finally, last but not least, reinforcement learning from human feedback, or RLHF, uses human feedback to train a reward model and then optimizes the large language models like LLM, using reinforcement learning to align with human preferences and improve output quality. As you know, we talked about those concepts briefly in Module 1. When to use each approach? And it's the best question. Scenarios, we have scenarios and a recommended approach. For example, if the scenario is frequently changing knowledge, for example, company docs, it's better to use RAG. If brand tone or a specific response format is matter, fine-tuning is the best approach. Sensitive data that must stay internal, local fine-tuning, like self-hosted, it works better. It's a recommended approach. And quick demo or prototype, for this one, you can use RAG. And finally, production ready assistant with consistent replies. For this scenario, you can use fine-tuning, cloud, or local. It's up to you. And RAG, I should say that RAG is already being used in customer support chatbots that pull answers from knowledge bases, healthcare systems referencing medical journals, and law firms searching case databases, financial advisor using live market data, and internal company assistant for policy and HR help. It's becoming the go-to way to make AI not just smart, but reliable and domain aware. Um, to sum up, I should say that RAG is like giving AI a library and the wisdom to use it. Fine-tuning teaches it how to speak or behave, and together they create AI systems that are both knowledgeable and trustworthy. It's a difference between an AI that sounds smart and one that actually knows what it's talking about. Thanks for watching. This is the end of your journey as a beginner, and now you know enough to decide which parts you like to choose for the rest of your path. And I'm going to introduce some useful tools. If you have something special in your mind, drop in the comment and share your thoughts and idea. Don't forget to like and subscribe and share with someone who might be interested. See you soon and take care.